maybe going through a few numbers. Precipitation throughout the year. We average around 45 inches a year here in Kentucky, less so up in northern Kentucky and more so down in Bowling Green and whatnot. So about 42 inches up at Cincinnati, and down here in Bowling Green about 50 inches plus. So you're in that 40 to 50 inch range. During the summer months, precipitation wise, we do have these what we call popcorn thunderstorms, as Carmen was talking about earlier. Whenever we talk about precip measurements, yes, the more rain gauges the better, but those can drop a tremendous amount of rainfall during a short period of time. And it happened not too long ago over in western Kentucky 2 or 3 years ago. I can't remember the exact date. Some thunderstorms produced 8 inches of rainfall in less than 6 hours over there. So tremendous flash flooding. It can happen here in Kentucky. Typically, our spring is our wettest month of the year. You can see about 10 to 12, maybe even 13 inches of rainfall on average during the spring months. Our driest month is typically autumn, 9.5, 10, 11 inches of rainfall as you go south across the state. But like I said, in Kentucky, it's not always the case. September this year was actually, I think it was our third wettest on record for the state of Kentucky. But for Lexington and Louisville, we broke the all-time September highs. Snowfall. I put this statement up here. It's tough to exactly quantify. It ranges on a yearly basis. A couple years ago, one of our warmest years on record, we didn't see a whole lot of rainfall, or snowfall, I'm sorry. But other years, we do have these major snowfall events. Right here, 1917. Back in 2015, we broke records, 17.1 inches in March that year, with one snowfall event, 2-day storm totals. It happens. So, but on average, right here in Kentucky, average number of one-day periods exceeding 1 inch of snowfall. We're in this orange shaded color, 1 to 3 in January. Number of days exceeding that 1 inch in February. We're right there in that 1 to 3 category over a 30-year time span. So we do have major snowfall events here and there, but they don't happen that often. Only 1 to 3 times a year we get more than an inch near our area. Statewide temperatures, you guys know that range. We live close enough to the Gulf of Mexico. We get influence from the south. We do have polar air coming down from Canada. So we do have colder winters. We do have warmer summers, but not compared to our northern neighbors in Minnesota and our southern neighbors in Florida. So on average, our average temperatures during January statewide, 33.7 degrees. Maximum temperatures getting into the 30s, minimum temperatures getting into the 20s, pretty normal around here. Getting in below zero, it can happen, doesn't happen a lot. Western Kentucky is a little bit warmer compared to Eastern Kentucky whenever you look at normals going back. And even during the summer, temperatures are in the upper 80s, low 90s out in Western Kentucky. They were a little bit lower in the middle 80s over in Eastern Kentucky. So seems like there's always a little bit of a decrease as you go east across the state. So heat index, average number of days, heat index, what it feels like outside is equal or greater than 90. You're in these orange shades anywhere from 14 to 40 plus times a year. You get to 100, that number goes down, doesn't happen near as often, but 7 to 14 across a portion of the state, pretty good bet. Wind chill. This was that event I was talking about back in 2015, I think it was. And yeah, February 20th. Richmond, Kentucky got down to minus 32. We're here in Lexington. We got down to minus 13 at the airport. Minus 26 in Cynthiana, just to our north. Very low-lying location. So very cold temperatures on the morning. Frost freeze. So this map shows the climatological date of the median first 32-degree freeze during the fall. We're here in this light shade of green, which is October 21st to the 31st. So seeing freezing temperatures, we're getting closer. We're not quite there yet, but here in Kentucky, we flip that switch. We could go cold weather pretty fast. Go to the spring. Average last 32-degree freeze so we see in Kentucky or Lexington in our area is this orange color, April 11th to April 20th. So we're not in the all clear when it comes to warm season, planting warm season vegetables, tomatoes and whatnot in the ground, but at least at that time you're on the downhill trend where freezes become less of a possibility. So I want to tell you guys all, if you get on your computers, you go to weather.uky.edu. That's our website. A lot of this information you're seeing right now is going to be on our website. This is the spring and fall frost freeze normals. You look at this data, you look at this middle section right here. It's really the average date you're going to see your first freeze or your last freeze in this area. We look at the fall months. We normally see our first freeze here in Lexington on October 27th. Our latest would be November 10th. We saw our first freeze, and our earliest we saw it on October 4th. Going the other way, spring, we have had some late freezes. You can see you get into Ashland. They had freezes occur in June and July at some point over the past 30 years. So sometimes you're not even in the out of the woods in the summer. Lexington climatological norms. Just put this up here since we're here at UK, looking through the winter, spring, summer, and fall months. You can see we average the most rainfall here during the spring months, 12.93. That number stays about the same during the summer, but diminishes down into that 9-inch category toward the fall. 45 inches of rainfall on average here in Lexington, though. Snowfall, like I said, it's hard to say, but February is normally our snowiest month, average of 4.6 inches of snowfall. That number diminishes till you get to December, 2.5 inches. So we don't get a whole lot of snowfall around here compared to the northern states, obviously. So how has this trend went across the years from the late 1800s to where we're at here in 2018 whatnot? You see this fluctuation up and down trend over the course of the past century, but I wanted to show you guys here. You see the average throughout those years, but there are dry years, there are wet years, there are warmer years, there are cooler years. So there is fluctuation. A couple years ago I called it a year without winter because it stayed warm the entire time. Everything was green up so early, and everything was popping. We did have some freezes that year, but precipitation wise, 1930, very dry year. You see that blue line compared to the rest of the years. 2014 whatnot, we were quite a ways up, one of our wettest years on record. So it fluctuates here in Kentucky. Wind speed, wind direction, real quick. Our predominant wind is from a southerly southwesterly direction, and that's no matter what time of the year. Some people might think, okay, it's winter, it's getting colder outside, we're going to the northwest. Well, no, that's not the case. Our predominant wind direction during the winter, this is the January wind rose, is actually from the southwest still. So stays the same throughout most of the year. Drought. We have drought about every year. Around here, it's normally short-term drought. We were talking about agriculture earlier. It doesn't take much during the summer months. You see 2016 show up here. We were in red extreme drought at that point in time. That's whenever we were having all those forest fires. But you can see these red shades, extreme, exceptional drought. You don't see very often going back to 2005. Only a handful of times. We felt it bad late 2007, early 2008, again 2009. We saw it again in 2012. But for the most part, we have typically short-lived droughts here, abnormally dry to moderate drought categories on a yearly basis. Like I said, they don't last very long. We're lucky with that. So short-term droughts, hydrological droughts, long-term droughts don't happen a whole lot here in Kentucky. Severe weather-wise, this is the annual number of thunderstorms we see across the United States every year. Greenish color, anywhere from 40 to 50 thunderstorms. That number increases as you go farther south. You're closer to the moisture from the Gulf of Mexico and Atlantic Ocean, obviously warmer temperatures, a lot of instability down there, a lot more lightning in Florida. We call that the lightning capital here in the United States. So over 100 thunderstorms there next to Orlando. Severe weather probabilities. You guys hear severe thunderstorms issued throughout the year. In order for a storm to become severe, you have to have wind speeds in excess of 58 miles per hour, or you have to have hail in excess of 1 inch in diameter, or maybe you have a tornado in that situation, or the possibility of a tornado. So our uptick in severe weather is May, June around here. That's whenever our highest probability of seeing severe weather is. Tornado probabilities, we peak out early May. You can see the bullet or bullseye is out in Oklahoma at that time. Bigger tornadoes. Once again, like I said, early May. We peak out in tornado frequency across the United States in May and June. That number goes down, but what I want you guys to see from this graph, we have a less intense, I'll say, tornado season in November each year, a little bit of an uptick. Tornadoes can happen any month of the year, but we are coming into a slight uptick as we change into that winter season. We have a warm air and cold air competing across our area. Average number of tornadoes per hour of the day, they happen later in the day. We need that heat, we need that instability to build up. Normally it's occurring in the afternoon, evening hours. An average number of tornadoes across the United States per year, we average about 21 in Kentucky per year, but just like snowfall, don't put a whole lot into that. That's going to vary from year to year, and it could be skewed based on one major tornado outbreak. So, all right, guys, I'm done. I had to go through all that. I had to give you guys the facts about Kentucky. I had to give you guys input on the weather elements just so you guys can get into weather forecasting, all right? So now we're going to start talking about why we're seeing what we see here in Kentucky as it comes to the weather. So it's all about location here in Kentucky. Where we're at, we have what you call air masses located all around us, all right? Some of them are colder, some of them are warmer, some have more moist air, some are drier, all right? These are basically large masses of air similar in temperature and humidity characteristics. Up to our north, we have continental polar air masses, all right? Cold air, dry air. That's when a cold front comes through the area, we get awfully cold outside. We got warmer air to our south, maritime tropical air masses, the Gulf of Mexico. I know they were talking about the National Weather Service last night. This moisture in the Gulf of Mexico, that's where the majority of our moisture comes from here in Kentucky, because we're blocked by the Rocky Mountains here in the western United States from this maritime tropical moisture coming from off the coast of California and whatnot. We got the Appalachians here to our east that's blocking this maritime Atlantic air. So that's where this comes from. We live here in Kentucky. Winter is coming. Nope, that's not the case. No, we're going to go cold. No, all right, warm again. So that's all because these high and low pressure systems are rotating through the United States. Now, very important when it comes to weather forecasting. Everyone paying attention. This is probably one of the biggest take-home aspects I want you to go home with today. We got high pressure systems, a blue H on surface weather map. We got low pressure systems, a red L on surface weather map. Now, how can I tell these are bringing me cloudy, wet, clear, dry weather? High pressure systems, a lot of air is descending through the atmosphere. It gets to the surface and it pushes out. As this air is descending, it's warming. High pressure, I want you to associate with clear, dry weather, all right? Just to make it easy, whenever I go and talk to elementary schoolers, I say high pressure, okay? Might not know about high pressure, think happy weather, all right? Elementary schooler, that works. Kindergarten, so H, high pressure, happy weather, clear skies, dry conditions, all right? Maybe that'll stick in your minds like that. Low pressure, exact opposite. We got air rising through the atmosphere. As that air rises, it cools, it condensates. Sometimes you get precipitation. Whenever you see an L on a surface weather map, I want you to think cloudy, wet weather. Once again, going back to kindergarten, say L for lousy. So you're teaching weather to smaller kids, they can get this stuff too. So we got lousy weather and happy weather, all right? Now, winds rotate differently around high and low pressure systems. As I said, winds move up through a low pressure system, condensation, precipitation, but they rotate in toward the center at the surface, and they're rotating in a counterclockwise direction. So low pressure, cloudy, wet, counterclockwise direction. Everybody got that? All right, I'm going to test you here in a second. High pressure, exact opposite. It's getting to the surface, it's pushing out. Those winds feed into a low pressure system. They're all working together. High pressure system, wind descending, winds are rotating clockwise around the center of that high. So high pressure, clear, dry, clockwise rotation. Low pressure, cloudy, wet, counterclockwise rotation. All right, guys, let's put it to use. You guys are the basic forecasters right now. We got low pressure up here in southern Canada. We got low pressure down here, panhandle of Florida. We got high pressure right here on the East Coast. All right, I'm just going to single you out over here. I'll go around the room, okay? H. What kind of weather are they seeing at these two locations right here? Good weather, clear skies, dry conditions, right? Okay. All right, so we got Greenville, North Carolina, Scranton, Pennsylvania right here. All right. All right, now we're getting a little harder. Sorry, she went high pressure. If you're in Scranton, Pennsylvania, where are your winds going to be coming from? Uh-oh. Okay, hold on. First, is it clockwise or counterclockwise? Clockwise. All right. So we got clockwise wind direction. Where's your winds coming from in Scranton, Pennsylvania? Anybody? So I would say, do what? Southwest? That's what I was going for. So southwestern direction. All right. If winds are coming from the southwest, all right, let's go to the next person. All right, you're up, okay. Winds are coming from the southwest. What type of air mass is being pulled up into Scranton, Pennsylvania? Is it coming from here or down here?
Down south.
Down south. Man, you're cheating over here, right? So, clockwise rotation. We're pulling up warm, humid air from the Gulf of Mexico into Scranton, Pennsylvania. So maybe a nicer day there, warmer day. This was taken in January, so in Scranton, Pennsylvania, they might be welcoming this high pressure system just to their east. All right, let's go back to, I'm sorry, names are terrible with me, so I'm going to say green hat. So, Keeley. Okay, Keeley. Let's go down to Greenville, North Carolina. Now, this is the interesting concept because winds are rotating clockwise. So even though you're really close to that high, it might be a totally different day, another location around that high pressure center. So clockwise rotation, right? So where would your winds be coming from in North Carolina? Do what? Other direction.
She said southwest.
Okay, so we're going the other direction now. So there's southwest into Scranton, northeast, that's perfect, all right. So they're getting a southwest direction in Scranton, Pennsylvania. They're getting a northeasterly flow into North Carolina. You're in the middle of January, you're getting northeast wind in North Carolina. It's probably not the greatest in the world, okay?
Matt, can you show how you know the size of the circles that you're drawing through?
Those are general. I'm just going clockwise direction right now, but you can look at these isobars across here. These blue lines are lines of equal pressure, and those will help you trace out pressure gradient, how strong the winds are. The closer these are together, there's a higher pressure gradient. The tighter they are, the higher the winds are going to be. So that's, as I was talking about earlier, pressure is directly correlated to your wind speeds outside. But you can get an idea of motion based on all these isobars. But it's something clockwise direction, counterclockwise direction, something to memorize. So, all right, let's go down here to this low pressure system. All right, red shirt.
Yeah, I'm Ashley.
Ashley, okay. What direction are winds rotating around low pressure? Counterclockwise, all right. So we're going in this direction now. Where are winds out of in Tallahassee, Florida? Southwest, certainly. Perfect. All right. We're getting there. All right. Right here. Oh, wait. We're going here. Sorry. Low pressure. What are you thinking conditions-wise?
Lousy.
Lousy. Hey, that works. That works. Cloudy, wet weather down in Tallahassee right now. Not the greatest. Okay.
And then the wind speeds are just not so much because the...
Exactly. So as Carmen's talking about, you guys see these isobars are a little bit farther spread apart compared to maybe a little tighter up here, especially right here, they're really tight. So
that means the storms will kind of sit on the city for a while.
yeah, there's not much flow. So, and we'd have to look at upper levels too to really decide that. But yeah, so all right, let's go up to Duluth, Minnesota. All right, this is January 23rd. A lot of people probably aren't liking the weather right now. All right, right here, low pressure, what kind of weather? Pretty poor. Okay, cloudy, wet. All right, winds are rotating what? Counterclockwise. All right, what's the wind speeds coming from in Duluth, Minnesota?
Where's it coming from?
Yep. What direction?
Southwest.
We're going the other direction now, so.
What's
This-
down from the top? So
Yeah.
northwest.
Yeah, exactly. Where the winds are coming from. No, that's perfect. All right, so I missed you back there, guys. I'll get to you. So, but I'll remember you guys when the forecast is up. But so you guys are getting a general idea. You guys will also see these frontal boundaries attached to these low pressure systems on a surface weather map. Whenever you see these frontal boundaries, a red line, semicircles on top of it, pointing in the direction of motion of that warm front. It's a warm front. Blue line, triangles, cold front, all right? These cold fronts are normally the ones that bring this storm systems through our area. Warm fronts is more of a light to moderate, that stratus cloud type of precipitation. So Warm front air is gently descending over colder air, and cold front a very abrupt lift, and that cold air hitting that warm air and pushing up in the atmosphere. But your take home, low pressure system is associated with what? Green sweatshirt.
Rose, sorry, you're up.
Low pressure system is associated with what?
Poor weather.
Okay, and these are attached to the L. So what do you think these are associated with? Poor weather.
I'm sorry?
Poor weather. So frontal boundaries bring cloudy, wet weather also. And you can remember that because they're attached to that L. So run out of time, so I won't go too much into these, but cold fronts are what they say they are. They move through our area. You got cold, dry air coming from Canada descending into Kentucky. During the summer months, it's nice to see. During the winter months, we hate to see it. Ahead of the cold front, just with that rotation of low pressure, the counterclockwise rotation, we can always expect to see warm, maybe a little bit more humid air out in front of these cold fronts and behind the warm fronts. And then once the cold